Now sometimes it says live and the stream starts like a minute later, so
Yeah.
it says we're live, but let's see how that actually goes. Okay, hello everyone. Welcome to True Zero Emissions, where we are here to learn. What are we going to show now? Okay, what are we doing? So we have a plasma ball, which is a Tesla coil. Plasma balls have a Tesla coil inside. It's down inside. And that's why when you touch this, you see this. Now what's interesting is Cameron's here with me.
Hello, people. Hello.
Let's see what the meter's going to read here. Let's put it on AC, and let's zero the power out.
You are running.
Oh yeah, so it's good. We're good. Oh good. That you? Okay. Let's see what this does when we put the meter on top of here. So it's reading. It's showing 3 amps. And this Tesla coil, this is, by the way, this is a huge speaker magnet down here. When we brought that close to the Tesla coil, the meter just went really super crazy, right?
Mm-hmm.
It just it started making a lot of noise, and I thought I blew it out, but just by putting this meter close to the Tesla coil, it's what it is. It's a plasma ball Tesla coil, okay. It's showing 3 amps, okay? So take it away, and you can see it's at 0.08 amps, okay? So I bring it closer. We're back at 3 amps. Okay. The Tesla coil, plasma ball, butterfly, is powered by 5 volts at half an amp, or 500 milliamps. That's half an amp. That's 2.5 watts to power the plasma ball Tesla coil. And we're getting 3.5 amps here in AC. It's set to AC, alternating current. Okay, and let's see what kind of voltage we're getting. Because you multiply amps times volts to get the watts, right? That's how we do it. Okay, so let's see. Now this coil, so this big speaker magnet here had this coil in it. It was from a speaker, and I just put this coil here, and I connected the wires to each end of the coil, which is just where it connects to the speaker, usually. So that's been separated, and this is just here. So from the coil, let's read what the coil says. I don't know if you could see my... We're talking about having a stand that holds the meter, like, close. Would you?
Yeah.
Thank you. That would be very helpful.
Yeah.
Lower? This way? Right there. Okay, so I'm going to connect these to the meter, right? Yeah. Oh, where's the meter? Oh, okay. Okay, so this... Okay, so this is the meter wires. And it's on AC, and I hope it doesn't blow the meter up. Oh no, the meter's going crazy right now. It did not like that.
Okay.
It might be because the magnet's there.
Do we want to do our magnet in, magnet out condition?
Let me try one more time. Didn't we just do this and it worked? I thought we
Yeah.
just did this. Oh, the meter did not like that, did it? Let me try this. Let me turn it off, and I'll connect it, and then I'll turn it on after it's already connected. Maybe that'll help.
Mm-hmm.
Okay, let's try that. Let's try that. Okay. Okay, there we go.
That was what did it?
Yes, that did it. I just can't connect it with the meter's on. The meter has to be off. It's just too much. The meter makes all kinds of noise sometimes, and the screen goes different. Okay, so 60 volts AC. Let's bring it really close. 60 volts AC. Now, that's connected to this coil, which is a speaker coil. It was a very big speaker, and that's the magnet from the speaker. We don't know what the magnet's doing right now. We don't know. Cameron said, let's put the magnet in there. I said, yes, that's what I took it off the speaker for, is to experiment with it. We each definitely, it helps to talk about what we each see, right? We come up with ideas and everything. 60 volts AC. And how many amps did we? You just had like 3.5 amps, I think. That's a lot more than 2.5 watts, which is what we're putting into this.
Okay.
What we're thinking about is how can we use this energy? Like our meter's telling us we have energy here. It's telling us we have 60 volts at about 3 amps, which that's 180 watts, right? 3
Sure.
times 6 is
I'm
18.
gonna go with your math.
Okay. So we have a lot more than 2.5 watts going in. We have, let's say, 180 watts or so coming out of this coil. Well, let's look what our readings were. We read our voltage from the coil, but we read our amperage with the amp meter from the top here. Oh. So we're trying to figure out how to use this energy to turn a motor, to light a bulb. I mean, I know this is lit, but, you know, I think to turn a motor, right? We want to turn a motor with it.
Yeah, we want to do work, basically.
Okay, so what do we do now?
Well, I tend to want to connect the ends of the neon tube to something and prove that we can take energy.
Prove?
Oh, and observe that we can
Observe. We're not proving anything.
observe that we can take energy from it.
We're observing and learning. We're trying to teach ourselves how to use this energy. So we're in a sea of energy, right? We're in a sea of energy. We literally are in a sea of energy. The Tesla coil is interacting with the energy all around us. I don't know if it's pushing it away and the energy wants to push back, so it's a pressure, and then we can use that motion to do work, maybe.
Mm-hmm.
There's different ways to think about it. I don't know how to think about it yet. I'm trying to learn how to think about it.
Sure.
But I always come back to, what can I do to see the energy move? Not just making light, but maybe to move a motor, to spin a motor, yeah, light's good. Lighting, lighting things. Look, this bulb is just touching this Tesla coil, this plasma ball, and let's see if we're getting any amps from this. Okay, so let's put this around here, and let's see if it's giving us anything at the moment. Okay, well that's reading, let's see, let me take it off. Okay, so it's a 0.05, and then when it's on, it's 0.5. Okay, so it's reading something. Oh, that magnet it's touching the magnet. I don't know if that's affecting it. Okay, so when I go up here, it's 2 amps. 2 amps. I don't know if that can be seen on there.
So you're saying that up and down the neon tube,
Well, no,
it's different readings?
When I go close to it's grabbing the magnet.
Oh, I see.
I don't know what that does. I don't know what that does.
Yeah.
So, yeah.
I believe that those things, what is that meter called again?
Amp meter.
Amp meter? Something makes me think it's magnetically affected inside. Could it be that it reads a magnetic field? I could be wrong. I feel like I heard that.
Thomas Bearden talks about how the meter, for example, he doesn't say amp meter. I think maybe he does. I don't recall exactly how he said it. But what I saw when he was teaching about this, like in his lectures and videos and seminars and the material that he shared, is that when we take a reading, we're reading the dissipation. But the dissipation, what's being released from a wire, for example, from something, matches the energy that is flowing, maybe, let's say, into the circuit. It matches it. So what's being released is also being, because everything's interacting with the environment, right? So I don't totally understand that, but if what we're reading is the energy being released, but that matches the energy that's flowing through, right? What was your question?
I just thought I remembered those acting it's as though you've got a magnet and a piece of metal or something.
Yeah.
And when you bring that near the electrical field, it brings them closer together, and it's the fact that I might just be talking out my hind end.
If you talk about an electric field, there's always a magnetic field, the counterpart. That's what Don Smith teaches.
Yeah.
Electromagnetic. So if you have an electric field, you have a magnetic field. If you have a magnetic field, you have an electric field.
Mm-hmm.
And there's supposed to be ways to extract energy directly from magnets. I don't know exactly how that works yet.
Mm-hmm.
Don Smith talks about if you know the frequency that a magnet is vibrating at, because I guess it's already vibrating all the time, then you can extract the energy directly from it. You just have to know what the frequency is. But once you know what the frequency is, what do you do with that? Do you send that frequency in to the poles, the north and the south, the positive and the negative, or the minus and the more negative, negative and more negative? Like, I don't know. I don't understand that part yet. But so what should we do now?
The motor. Earlier, when I came
gosh.
over, you had, where's that small motor?
This little one?
So Joseph had this little small motor set up. I think you had it set up when I came, right?
Yeah.
And you had it spin it. You had it set up, attached to your, I'm going to call it your power pusher. It would spin a little bit. We could grab our finger and twist it.
But you suggested putting it to a battery.
Yeah, somehow it didn't seem to want to keep itself spinning, although it had almost enough power. And I thought, why don't we get it spinning? And part of what I was thinking after that, which I didn't get to so much, was once it's spinning, could we take the battery out and just see if this system can power it? But in the meantime, though, connecting it to the neon tube and connecting it to a battery it's used to receiving energy from, can that spin it? Joseph took that and then he went to his rectifier idea. So I say, oh, let's add a battery. Joseph says, yeah, let's do it. And then Joseph says, well, look, I'm putting it in the rectifier. And so we both kind of morphed our ideas together. And so how do you get your motor in there again?
These are magnets from the John Deere alternator.
Mm-hmm.
I mean, I don't know if I should put these down there. I guess I can drop these in there, right? I feel like putting lots of magnets is okay.
You want me to hold this while you hold that?
Yeah, I have to take this off.
Oh, you're going to take it all the way up.
And would you hold it?
Yeah.
Just hold it right there? And I'm just going to slide this magnet down, since we're putting lots of magnets in here.
Watch out for wanting to smack and, attach that other one violently.
These are just John Deere magnets. Why not, right? Let's just see if it does anything. Okay, lots of magnets. Okay. Connecting this back up. And then let's put our speaker coil back on. And Cameron, feel free to just come over here and start plugging things in if you have an idea about something.
Sure.
Okay, so let's see what the mirror is going to say right now. Okay, right now, what's the meter reading? It's reading... Oh, that's very strange. Wow. The voltage... It's down to like... Wait a second. Oh, I think we just plugged one in. Yeah, there it is. So for some reason, just having one of the wires plugged in...
Why don't I show the people at home?
Good. So when I connect...
So they can see all of it. Okay, so we can
Go
see
down more?
this, and then we can see what you're... If I bring it here, then we'll see what you're doing, kind of.
Okay, but that covers the Tesla coil.
There?
Yeah, that's good. Perfect.
Okay.
So the two wires coming from the speaker coil, which I put around the Tesla coil, the plasma ball, when one wire is connected, it's reading 33 volts. You have to go down. You can see it? Okay.
Yeah.
When I connect both wires to the meter, it drops... Oh, did it drop? Oh, now what's it doing? Oh, that's so strange. 58 volts. Wow. Maybe it's just a bad connection? I don't know how to understand what's happening right now. Is this fun?
Yeah.
we have good numbers. Like, I know the numbers are good. We have 58 volts right now just from the coil. Let's see what the amp meter reads here. Just revisit that. Now it's from the coil. Well, since we're doing coil, let me try reading if the coil will give me a... I don't know if this is going to be able to show on here. I'll go around the coil. And that's showing 3 amps. that's good. So we're reading 3 amps at 3 amps around the coil at what's the voltage? Would you do it, Cameron? Is it? Let's see if it's different when you're doing it. No, it's 25. Okay, so right now it's reading 25 volts. That's 75 watts though. 3 amps times 25 volts is 75 watts. So that sounds like it's enough to to power something. Let's see. There's a bulb.
So how does that happen? What is that?
Look at this. I mean, it's just something I was doing. I was touching this with, and there's people that have done this on YouTube. And
what kind of bulb is that in your hand?
this is a LED bulb.
Okay.
And I'm just, now when I touch it, it's not going to do anything, right? If I touch it on there, the end of this bulb, the end. But if I touch here, then it turns on.
Your finger is...
Yeah.
Oh, so one pole is touching the pole of the neon tube, and the other pole, the other less negative or whatever, is your finger making...
Well, I don't know if it's less...
traditionally known as a ground.
I don't know. Yeah, I don't know if it's less negative or more negative, right?
Okay.
I don't know. But yeah, one of those. So if I touch, so there's metal here and there's metal here, right? That's the two you usually power, is those two, right? So if I touch there and I ground to this, the bulb doesn't turn on. But when I touch here, it turns on. See what's happening? Well, it turns on. What does this one do? It gets dimmer.
To lose some of its potential.
But this is still connected to something else. Let me disconnect that. That's still connected to the bridge rectifier from earlier. Let's see if that changes anything. No, but let me see if I touch this side now. Now watch this. So if I touch... Oh, wow. Now I don't even have to touch it anymore.
You don't have...
Oh, but it gets brighter if I touch it. It gets brighter if I touch it. Okay, let's see what happens with this bottom one. So I'll keep touching that one. Okay, that doesn't do anything. But okay, so if this one's not connected and I touch this, it gets brighter. But here's the thing: how do we work with, like, how do we make it power?
How do we?
As
use
Don
that
Smith says,
on our
yeah.
scooter?
Yeah, as Don Smith says, how do you make the energy usable? Don Smith always says that. He says the first thing has to be in your mind how to make the energy usable, or you'll never get there. Because you can get distracted endlessly with different things.
Mm-hmm.
So Donald E. Smith, Earth Electrical System 2, and Resonant Induction Energy Transfer, Donald E. Smith. How do you make the energy usable, basically?
The power supply going into the Tesla coil, you said, is how many volts, how many amps?
The last reading from the Tesla coil to the speaker coil, which came out of a speaker, I was getting, I think it was like 3 amps at 25 volts, the last reading. Because it changes depending, it can change.
And this power supply here, what is this rated?
5 volts, half an amp.
So 5 volts, half an amp is like what in terms of batteries sitting around? How many AA batteries is 5 volts, half an amp? Three or four battees stuck in.
Okay, so AA batteries
series?
are
1.5
1.5 volts each. So it would be 3 of them would be 4.5. So it would be like it would be 3 would give you 4.5 volts. It wouldn't give you. You'd probably need 4.
Do you think that we could take 3? I'm not saying it now, maybe for next time, but if we took 3 AA batteries in a case or whatever, just stuck the wires going into your Tesla coil, would that turn on the Tesla coil, do you think?
I like that.
Because then it's transportable.
And then it's just kind of running itself.
And then this bulb.
Oh, I see what you're saying.
How do we harness it? We harness it because we want to ride our scooter and have some light.
Yeah.
That's what we want to do.
You want light, I want more range.
You want range, I want light, I want range too.
And if you want range too. Okay,
I want everything.
I mean, yeah, and if I can get an extra mile or two, I would be very happy with that. But
Right.
then you just keep going. You're just like, okay, you got 2 miles. Can we get 3 miles? Can we get 4
Yeah.
miles? Right?
Yeah.
Okay.
So this, could we on a piece of paper draw it attached to our scooter? Tesla coil, battery, maybe a switch. Neon tube, you're saying, is necessary or is not necessary?
I don't know.
Okay.
I don't know what's necessary and what's not necessary right now. I'm trying to keep a really open mind about how to translate this energy into something we can, that we want to do.
I have this idea. My idea is forget this bulb,
Mm-hmm.
which I feel like if I just touch my hands here. Why don't you touch from there to there and see? You might have to touch me. I don't know.
Oh, okay.
I'm feeling a little zingy in my body, but okay. Maybe we don't hold enough energy. Part of what I was thinking is
Well, we're not. I wouldn't say we don't have enough energy. I
we're
would
not
say
harnessing.
we're not.
pushing
We're
it.
not connect. We're not plugging in correctly.
We're not utilizing it.
Yeah, we're gonna figure. We're gonna keep figuring this out, though.
If I touch this bulb to this glass terminal, is it going to turn on? So look, I just eliminated this.
Okay, do it again,
Okay, you know what
please.
I'm saying?
Yeah, it's
There's
not in the
just a
frame
little
though.
bit.
It's not in the
Oh,
shot.
okay.
Here, let me adjust the camera.
And I don't
No,
want to
go
burn
ahead.
it
Go
out
ahead.
all
I'll
of a sudden. You know what?
come this way. The frame's big over here. Yeah.
I'm not sure if I'm doing the best thing for this.
Hold
I don't
it there.
want to kill it and burn
No,
it
no,
out.
it's not. It's not.
It's not?
No.
Okay.
Or I can get another one if we need to. So hold it there. Hold. Yeah. See what it'll do. I want us to learn. So anything you can think of, do that. That's very bright. That's good. That's
Okay,
bright.
this is brighter.
Yeah, that's really good.
So look.
Oh, so
we-
it's amplified over here.
Yeah, where I think we might be determining.
Yeah.
You know what? Maybe it's just the connection. This gets bright. Maybe this just that it's metal on metal. Use.
But we can also
work.
wrap this with tinfoil,
Yeah, yeah.
right? And then that'll be a connection too, right? We can wrap this with tinfoil. I'm just saying.
Yeah. To me, work is a motor turning or a light on, and that light on putting out sufficient lumens that it's useful for us to have on. So we just made it so it's more useful by having it go through the neon tube, but it was still useful just having it go through touch the Tesla coil.
So what are you thinking?
You've got small neon tubes, right? Those little light bulb looking things are neon
Yep.
tubes?
Yes.
Do those illuminate right next to it? Oh. The ones at this side.
Let me adjust the camera so we can keep everything in, show everybody. So if I don't touch the metal, watch how this works. So right now, oh, it lit now. It lit. Okay, it's lit. Okay, so right now, look at this. You see what it's doing?
I feel like I want to stick this here and see what happens. Nothing. It's not enough of.
Touch it to the metal though. Touch it to metal.
Yeah, there's a little, but it's not the maximum. It's not like this brightness. This is the brightest. This is the less bright kind of situation. This is the not making any brightness. Some brightness.
Do you see what's happening when I touch this though? Look. Watch. Okay, it's not doing it right now. So as I put my finger here, it'll light these up over here. Let's see. See?
So it's like you're affecting the energy.
Or I'm completing the circuit.
field.
I'm completing the circuit, right? By touching it.
Yeah.
But where did you want to go with this idea? What were you thinking?
I was just curious how it relates, so we've got this light turning on a little bit here. We've got this light turning on pretty good here. What happens here? Just not as much va-boom. Okay. Other things. Do you want to get that motor involved in there?
For this or for the other one? Because I was thinking with that one, with the high voltage 500 volt system.
Well, I've got this motor,
With what?
and you had it attached to what? This.
We could try different
and
things.
The rectifier.
Yeah, we could try. Let's see, this motor's in. Yeah, we could try different things. Do you want to try that again? I mean, here's the
Unless
thing.
there's one pressing for you. Go ahead and do it.
No. So here, I just want to review something real quick. So this is pulsing at I don't remember the exact cycles per second, but it might be like 20,000 cycles per second, right? This is the Tesla coil is cycling the frequency. So it's approximately, I don't know plus or minus how much, but it's cycling fast. Okay. Actually, we could probably read it. Let's see if it'll let me read it in my meter here. Let's see if it'll just let us read it.
Well, that's the commonly described story of neon tubes, that they pulse light on and off at a very fast rate, and I believe there's something about people with epilepsy possibly being susceptible to seizures because of the flashing. Because I know some epileptic people will have a seizure if there's flashing that their eyeballs can see. And I've actually had some people tell me that fluorescent tubes bother them, like just make them have some sort of uneasy feeling.
Cameron, what are you talking about right now? Because I lost track of what you were saying.
The on-off nature
Oh,
of this energy that we're dealing with, and the on-off nature of the pulses of light coming out of
41
gas.
kilohertz. So 41, is it 1,000 cycles per second? I guess.
I guess so. That makes sense.
Okay, so that's pretty high. 41 kilohertz. Okay, so that's a very fast pulse. And we may need, or one of the things I'd like to experiment with is, so we're talking about like Donald Lee Smith, right? Don Smith, there's a book, he has a book, and where's the book? Okay, it's called The Don Smith Magnetic Resonance Energy Crafting Systematic Index. Last I looked, it was available on Amazon, and also Rick Friedrich sells the book on his website, which you can find. You can first find his YouTube channel, Rick Friedrich. Okay, so let's see. What was I saying? Oh, Don Smith talks about, and I'm going to use my own words when I say, because I don't know if he uses this word, but it's what I'm thinking of right now. Translating the energy, right? Making it usable. So to me, I think of translate. How do you translate the energy, right? So it's this energy. How do we translate it to usable energy, to something that can move things that we need to move, like our scooters, right? So if this is such a high frequency, how do we, one of the things he talked about was, how do we change, so this is AC, right? That's what the meter's saying it's AC, volts and amps. Then how do we change that into a pulsed DC, right? Now the full wave bridge rectifier that I have, I don't know if it's can do that with a high frequency like that, or if it's not made for like lower cycles per second, I don't know. So maybe if there's like a high frequency transformer, these are like all those electronics that I have parts, all these parts that I have right now that can be used, like maybe there's a, like in the televisions that were, all these things were being given away recently, and I have a microwave, I have two TVs, these big speaker magnets, all this stuff was just being thrown out, and I brought them home to extract the parts from them because they were just going to be recycled, and so I thought I would do a little recycling too, right?
It's like hundreds of dollars of parts for free.
Yeah. And this was from, I think it was the person that told me about it said it was listed on Craigslist. I just saw this when I was riding my scooter and saw a sidewalk full of all these things, and saw someone taking what they wanted, and they thought everything good was gone. But I saw 2 televisions, a microwave, and even a toaster oven, which I'm thinking, oh, that could be a good test for these.
Oh, it's got like timers on it, and
it could be useful.
Timer.
Yeah. And it just could be a good load.
Potentiometers.
Yeah, and I want to connect it to this, this pump, the resonance pump, which is the dishwasher motor. I want to connect it to that and see if what it'll do with it. If it'll run the, I mean, that's something we could actually do now. But I kind of want to focus on this a little bit. We're here now, And I don't know if there's anything else at this point to do with that right now.
With that or with this?
With this one.
With this, I think
We're kind of
we
stating...
could recreate what we did earlier, which was fire the small. Try to run the small motor.
Okay, let's do that.
Run the small motor with a AA battery.
All right, let's do that. We'll try to run the small motor. Okay, so I later plugged in this motor, which is like really sensitive to power, but the smaller one should take less power, right? So let's see. We're just going to recreate the original experiment.
And does the small motor have any writing on it that indicates anything about its specs or anything for it?
Let's see.
To me, it looks, just from my eyeballs, like a million little motors that run off 1.5 or 3 volts or whatever, just small stuff like a little fan would have, or a little...
Here's the thing, if I connect this, let's connect it. Would you help me with this?
Yeah.
I'm literally just going to hold. You do this side.
Yeah.
And let's just see if the battery will even turn this right now. It seems like it's not trying to turn it at all, but let me change the battery. Because when we did this earlier, this didn't make sense to us, but the voltage stayed the same when we had the circuit connected, but the motor stopped turning, and we didn't know why. So this is a different battery now, and we'll see if it turns.
Okay, once again, it's not... It doesn't want to just catch it all.
Maybe the motor just, like you said, I think you thought the motor might have just stopped working, right?
I mean, it's acting like it's stopped working, but it's also kind of... Because we tried it again with this battery pack later, which this is a what? It's 6 cells, but what are they?
It's 4.2 volts.
There's a 4.2 volt.
Now look at this.
Series, no, the parallel pack.
This is our more efficient. This is our general atomics, aeronautical. This is a servo motor. Now this one,
servo?
it's from a jet, from a jet,
Okay.
from a aerospace.
Oh.
Now watch this. This one will turn with this. It's very sensitive to power.
This one's turning, and it's turning slow, as though it's like a geared motor. Is it a gear motor?
No, it's just not getting a lot of power.
Oh,
This is like a 25 volt motor, and we're putting like 1.5 volts in it.
Okay.
But I mean, it'll let us turn it. I don't see why we can't use this in place of the other one. But here's the thing. Let's see what we can do with this. Let's see. We want to get this turning, right? How can we use the energy coming from this and use it to turn this motor? Can we do that? We're showing amps and volts on the meters, but what kind of energy are we interacting with here? And how do we allow that energy to flow through our motor? Right? That's the question I'm thinking of right now. So what do you think? Should we use this full wave bridge rectifier? Let's just connect this in different ways. I mean, I'm thinking we need to translate this into DC, but it's such a high frequency, I don't know if this full wave bridge rectifier, which is like a 40 amp, 250 volt max, you know, which is, I got that originally was purchased for the purpose of, I mean, should we just try connecting this in different ways and see? Okay, well, look, this is outputs. Okay, so we're going to connect the outputs. Oh, for the purpose of the alternator scooter, the scooter with 4 alternators on it. That was a couple years ago.
So what do we connect to?
That's what that originally was for. The full wave bridge rectifier was for those alternators. That was for that project. So right now I'm going to connect. So I just want to try different things. Let's see. So we can let's try connecting the coil to the full wave bridge rectifier. Let's see if it does anything. See, it's not doing anything. Now wait a second. This was saying that it had 3 amps at 25 volts not long ago. So this according to the meters, we have energy here. Now, is it my full wave bridge rectifier just not the right thing to use? I need a different kind of
what if you connect this coil directly to the terminals of this motor?
Let's try that. And just see if it does anything.
Because you said it's 25 volts. And
That's right. That's right. I was just telling you this is a 25 volt motor. Yeah. So we'll take those off.
We want it to be able to be seen on camera, so I'll hold it just like that.
Okay. But the thing is those were AC volts. This is a DC motor.
Okay. So
See?
now AC versus DC.
Yeah, and it makes sense that it wouldn't turn it, right?
So
Just based on that,
okay.
on that alone.
All right. At this point, this takes me back to our earlier observation with the small motor, and I said, let's put a battery in series with it. Can we go to that, add a battery in series, and get this to run, or would that not prove anything?
Well, we're not proving anything.
Yeah, we're not. Would it? I think it would run, but I don't know if we would have done anything too significant then.
Well, let's try. I think we should try everything we can think of and everything we can't think of, because then we'll really come up with something. Especially if we can do the things we can't think of. But how do we do things that we've never thought of before?
Experimentation.
Okay, so here's the battery. Now, my only concern. This is a rechargeable. This is a rechargeable nickel metal hydride battery from where? Where's it from? Let's see. Let's see what it says. IKEA. I didn't even know that they sold rechargeable batteries until I bought this there. Okay, so thank you, IKEA. All right, so
if you just connect this battery to this motor, does it go?
We can do that. The not concern, but the thought that comes to mind is we're going to be sending AC into a DC battery. But, like you said earlier, what is AC and what is DC? And how many different kinds of AC is there and how many different kinds of DC is there? When I say that, I'm talking about Gerard Morin's, I'm calling it Gerard Morin's because he's how I learned about this, dishwasher water pump drain motor. It's producing an AC signal, but you can touch it from what I've seen him do. I haven't tried it. I haven't touched it with my hands. I did bump it actually a couple times, and it just felt like a little, let's just say it this way, a shock from static electricity hurts more than this.
Yeah.
Like if someone shocks you by accident, that drags their feet or something, or something like this, that hurts more than this.
Okay.
And this is almost 500 volts.
Yeah.
So now the wall is AC as well. So right, so this is AC. The meter reads it as AC. The wall says AC, 120 volts, 110 volts at, I don't know if it's 15 or 20 amps. But if you touch that, that can kill a person. And it does.
Yeah.
If you look it up, you'll see that people, I think there's like 400 people a year that die from getting shocked by at home. I don't know if it's just at home or if it's with electricity altogether. But it's electricity like we have on our walls,
Probably
like that.
Deaths in the United States with the description being electrical accident or whatever.
Mm-hmm. And there's many different probably categories of that too. But but it hurts people. This doesn't hurt. This doesn't hurt. This doesn't hurt. The wall does. Okay, so but at high enough voltage, I think so this is at like 475 volts. At high enough voltage, if it's like really really high, maybe thousands of volts, then I think it would definitely hurt. It would hurt you. An example of that would be the telephone lines before the transformer. So between the power station and the transformer, that's
what they call high power lines. Is how they refer to them. Is it called?
Well, Gerard Morin refers to them as a high pressure resonance, resonance force, resonance flow. I think resonance flow. So what is resonance? It can be said to be everything that's in the universe. But what was your question?
Is that referred to as high voltage or high power lines?
From whose viewpoint?
From Edison.
I don't know what they call it. Yeah, I don't know what they call it. I figure I'm going to learn from the people that understand all this stuff and learn that language. And then when I get it doing what I need it to do and it's working and my scooter's going further and your light's being powered and your battery also has range extender on it, then I can go back and say, oh, what was that other viewpoint that, there's so much to learn in this that I'm really focused on it because that's what's going to help me, I think, get to where I'm going. You know what I mean? Sure. Okay. So, which is, like you said, to have your light lit and on your scooter and to have my battery range extended.
Yeah,
Or-
well, my extra light on my scooter to run without having to charge it at home.
yeah.
That's a pretty good goal. I think it's pretty reasonable.
Yeah, and according to, I mean, you could have your light running off a Tesla coil.
Just have to figure out which pieces to align together.
Yeah, we got to figure that out. I like what you said about running this into itself. I did see some videos on that where people have done that, so I think that would be a good step to take. With this particular one, this one doesn't have the ability to take AA batteries.
Yeah, okay.
These don't cost that much. I think they're around like $5, $10. I mean, you can get them for, you know, this is a small one.
Yeah.
But they don't cost a lot. Even if you get a big one, they're still, you know, around maybe $15 or $20.
Mm-hmm.
Amazon has them. Google has them. So I'll order one. I'll look for one that takes batteries on the bottom,
Okay.
and then we can do that experiment. Now it'll be really hard for me to not do that experiment until you come again.
Sure.
Until you come by.
If you do, I understand.
But we will definitely do it again when you're here.
Cool, cool.
But I'll work on that. I like your idea. I'm glad you said that. It's a very good idea. So, okay, so where were we? You said, so okay, so I was saying we're going to put this, what we understand to be what we call AC, into a DC battery in series, I think, and see if it does anything with the motor. That's a great idea. Why not? Okay, why not try it? Okay.
Cool.
Worst thing that can happen is the battery can vaporize and this table could disappear, maybe. But then we'll have learned something.
You know,
As long as we're still here.
I think we will be here.
This stuff's all still
Yeah.
replaceable. This stuff we can order this again, right?
Because in the end, we have this plugged in to the wall through a low power supply pumping off 5 volts for
Yeah.
everything we're doing here.
Yes.
So we're probably safe.
Okay.
I think. We'll see. We'll see.
I mean, we were getting like, I think earlier the highest voltage we read was like 90 volts AC.
Yep.
That sounds like a lot. That's getting close to 120. Okay, so, and we did get I think up to a 7 amp reading on top here. So there's some energy here. There's definitely a lot of energy here. But we know that though. That's right. We know we're kind of walking through a sea of energy. We know that. Okay, so let me see. Where are we? So here's the 2 plugs, and I guess either one can go to the battery, right? Either one.
I would
Okay, I'm doing this now. I don't know what this is going to do or not do to the battery. And do we want to go from the battery to the motor now? I guess.
So, do we want to use one of these little hands and support that clip in space at all, or this is safe floating in here for now?
For now, I'll say, yeah, it looks like it's safe floating, and and that's the base where that magnet will stick to is not over here.
Oh, okay.
So
it's not gonna
in the future,
yeah.
I'll make sure it's in the right place. I just didn't.
And this is a non-conductive magnet surface, I would assume.
I don't know.
I bet it's. We could figure that out.
That's a
but,
good question.
It'd be good to know for eventually.
Yeah.
For sure.
And Cameron's referring to the helping hands that was recently ordered. It's just these.
Much nicer than the ones that I noticed at Harbor Freight. The system that I was thinking of getting.
Yeah, this was the very big one. It's called Quad Hands.
Looks so nice.
Yeah, we also got fans for running the resonance pump motor, so these fans and everything. Okay, so let's see. Let's see. Where are we? Oh, yeah, series. So I need more plugs. So let me use one plug. Oh, there's lots of them here. Okay. This is plug
There's
here.
also 1 or 2 droppers over here.
Could you hand those to me?
Yeah.
I'm gonna hang them up so when I can always grab them from the same place and know that they're there. Because when I turn around, sometimes there's none there because they're all out here.
Yeah, it can be maddening to not clean up between projects. The
Yeah.
clean as you go method is the coolest. All the cool kids are doing clean as you go nowadays, I promise.
And then when you have multiple projects going simultaneously, oh wow. Okay, I have one side of the motor connected there, and what were you thinking the other side to connect to? Just
The
directly
other
to?
side, well, we could try direct connecting it and just see, does it spin, what happens.
Okay.
If it does spin, then boom, we've harnessed our energy. It spins. Ha ha!
That is so strange. How is... Hang on a second, this doesn't make sense to me. Wow. Cameron, how did you think of doing this?
Because
Cameron,
you
I just-
said there's volts and amps coming off that thing. Give me it. Put
Oh
it on
my
my motor
God.
and let's drive. We're done. Let's go ride, dude.
Oh, we got to get it on camera right here. Fist bump.
Boom.
Boom.
Seriously though.
Okay,
there's
Cameron, I just want to
volts
say something. I just want to say something, just so I understand this. Okay, I think I already told you. You got the job, right? Now you can use it on me.
I've
You
got like 8 jobs, dude. I'll give you a couple jobs. How about that? Take a couple jobs out of me if you don't mind. Yeah.
Cameron, anytime you could be like, Joseph, you're hired.
Totally.
I mean, you're just really, to me, you're like 99% of this project.
Hey, thanks.
I'm just helping
I'm
hands.
loving it, man. To me, this is Disneyland. I don't know if the folks at home have seen the fantasy land here, which is like everywhere. It's batteries and motors and wires and everything good. Everything you need to succeed. I love it.
That's great. Okay, so the motor's turning. And how? That's amazing. It's absolutely amazing. Okay, I'm so happy with this.
We didn't even need to add this battery to it.
I'm jumping up and
Oh, wait,
down.
the battery is attached to
The
it?
battery's attached.
The battery
Let
is
me
good.
let me say what's happening right now. This is why I'm so excited about this, though, and I'll say that right now. So the battery's attached. So this is our coil that came from a speaker, a very big speaker. I don't know how big. Well, I'll show you. Oh no, can I show you? Let me measure it. I'll measure it.
Yeah.
'Cause it's not going to really fit. And I'm not sure if that's what's helping this happen. I'm not sure if that's what's helping all
Let's
this.
call that an 18-inch. I'm just guessing.
It is an 18.
18-inch.
I don't
Anyone
know
who
if this-
knows stereos knows 18 is like ridiculous.
This is the speaker. You can't really. It doesn't fit in the camera frame.
No one uses a speaker that big.
That's what it came from. So the magnet came from the back of that right there. And I'll try to do this without damaging this whole project here. Our project. Cameron's in my project. Cameron, would you hold that on there?
Yeah.
So we're at. Yeah, you can see we're at 18. And if I turn it, you can see that we're at this. That's the speaker the magnet's running. And I don't know if that magnet. I don't know what the magnet's doing. It's doing something because it made the meter really go. Remember when we first connected it? That was before we streamed, but the meter just made all that noise and the screen flashed. We also showed the screen flashing on the stream. It just didn't make noise that time for some reason. So what's interesting about this is the battery. Okay, so this coil that's from that speaker. So we have the wires connected to each side here, and of this coil from the speaker coil. Okay, so the wire's connected to each side of the coil, right? And then it goes down, and one side goes through a battery, and it's connecting to the positive and coming out as the negative, and then going to the motor. The other side of this coil is connected directly to the motor. And Cameron, you thought of that, right?
I thought of that, and I'm thinking of more as we go. This is what I'm thinking.
I don't know how this is turning right now.
For one thing I want to do is
I mean, there
wanna
is a
put-
battery in there, but it's only on
Yeah.
one side.
I want to put a piece of blue tape on this so it spins
Let's
and
do
people
it.
can see it.
I wanna do it
spin,
too. Let's
so
do
that
it.
the people at home can understand.
Cameron, do you have any glue tape?
Yeah, I'm gonna get a piece of blue tape and do that. But what else was I gonna say about this?
Oh, please do. Take your time. What do you see?
What I'm seeing is, you wanna drive your scooter. This is a motor running. Okay. You also want to charge your battery. This is a rechargeable battery. This is pumping, moving, shoving, doing something with energy. I hypothesize that this here battery may not be lowering over time. I tend to want to measure this, say this specific battery has exactly 1.32 volts, and then measure it in 1 hour after running and see how many volts it has.
Okay.
I'm gonna get a piece of blue tape.
I like that you shared your thoughts on camera so that I can review that and take note of it. Because I'm probably going to forget everything you just said in 5 minutes.
That's why we record it.
I know.
Okay, yeah, so to make it more comprehensible for the home, just like to make it so they can see the motion. So here's my idea. If I just do that, then when it spins, people will just see it flat.
Okay, I don't think it liked that.
It was already not spinning when I got there. Did something get changed while I was outside, or did it?
I don't
just
know.
Sort of
It
run
must
out
have
of
just
itself?
stopped. It must have just
Okay.
stopped. I don't know why.
Okay.
Okay, well, okay, let me unplug this. I don't know what's happening.
Um,
That was neat while it was going.
yeah.
And we don't know what happened, why. Okay, should we try changing the battery and see if that
Yeah.
changes anything?
Yeah. That doesn't hurt.
Just to see if that does anything. Okay, so we'll use this other battery now. And should I try turning the battery around now in a different direction?
Good. I didn't see why that would work.
And just see if what it does? Because we want to just try everything, right? I mean, to me, even if it's draining the battery, it's still interesting that it worked
Yeah.
somehow. Okay, what am I doing? Am I doing this right? Let's see. Where does this one go? This one goes... Oh, I think I'm confusing myself. No, this is the total wrong wire here. Okay, so this wire, I think we were going through... Okay, so this time we'll do it this way. We're going to go into the... Hang on, so last time it was like this, positive going in. Cameron, can you remind me? I'm totally lost here. I'm totally lost.
So
Oh, here's the wire. This wire was going into the plus side of the battery.
that makes sense.
So
Yeah.
now I'm going to
Yeah.
go into the negative side of the battery. Just to see what it does.
Mhm.
So we changed the battery because it stopped, and we don't know why. But we also don't know why it was working. And the time that it was. Now this one's going to come out and go to one side of the motor. And then the other, the circuit's completed by going to this coil.
Okay.
That completes our circuit. Let's do that. Okay, that's not making a turn.
Yeah.
Let's go back to the other way that we had it before.
One interesting thing I remember from being a kid and just having the same batteries and motors and wires for years and messing with them, sometimes the motor wouldn't run until you twist the shaft. Just sometimes they could sit there and not running, but spinning it could make it jump on again. That's just one thing I...
This is so strange. So this one's not turning. It's just not turning.
Okay.
Let me make sure I have all the wires connected correctly. Let me make sure this is connected good. Yeah, I did what you said. I'm pushing the motor a little bit.
Mm-hmm.
Let's see if the battery directly can just power the motor, just
Yeah,
touching the
yeah.
wires on. Let's just see if that works. Oh, let me put that tape back on. Okay.
Or I've got more tape if that's not good.
Okay. It's working.
Yeah?
Yeah. This is just for a visual, right? Okay.
Yeah.
So let's connect the 1.5 volt battery and just see if that...
Okay, there it is. It's doing stuff.
That turns the motor. Okay. Okay, so last time we had this coil connected in series. Well, I'm saying that, but I don't. Is it series? I don't. Going through the battery into one side of the electric motor. I mean, I'm already thinking about what's the next thing we're going to test. What's the next thing we can try? Whether this works or not. Like, I just want to keep trying different things, right?
Yeah.
I mean, that's really strange that it's not turning now. Last time it did.
Yeah, what is it about it?
That's
It's
so
like I want to
strange.
try this again with the known... No, we knew that rechargeable battery would run it a second ago. So we're kind of just getting conflicting results. What about go to the other pole and do this backwards of what you just had a second ago?
Let's try it like this.
Yeah.
Good idea. Okay, let me try this.
What if you swap those two? You know what I'm saying?
These two?
Just for the heck of it?
I see this light changing when I do this. See, like it's.
Oh yeah, boom.
Oh, it was the
connection?
connection.
The connection can
It
get
was the
zapped,
connection. It was the
Okay.
connection to the coil.
Okay.
I need to solder wires to that
Yeah,
coil.
That's okay.
Because I just scraped. I just scraped off the. Cameron,
that
that we almost missed this whole thing.
that could have like alligator
Okay,
clips coming off.
bump,
of it.
bump,
It could be
fist
so-
bump, fist bump, Cameron.
Oh yeah, big time fist bump.
Boom.
on that.
Okay. Okay.
That needs. Okay, so we're gonna call it coil.
Cameron, it was the connection.
Nice. Needs leads.
I'm already gonna sleep better tonight.
Sweet. Awesome.
Versus
And my-
not sleeping.
Yeah, and my 7:30 alarm went off, so I probably should go get dinner with girl and all that fun stuff.
Thank you
but
all for being here.
One of the other things that before.
Yeah, tell me everything
What
you can
else?
imagine
What
right
else?
Go.
Well, I mean, I imagine that. What if you had a Tesla coil on? Joseph and I are riding 2 scooters for a 10-mile ride. On Joseph's scooter, he has a battery powering a Tesla coil. On my scooter, I'm riding near Joseph's scooter, and I am using the push of energy from his scooter to illuminate my lights through wireless charging. Because this coil here is not connected. It's just sitting there. This is not connected.
No, it's just sitting there.
I mean, if I take it over here, does it still does? I mean, if I take it over here, the motor still runs.
Yeah, but this
But,
whole room is filled with resonance, right?
Yeah.
So I wonder if we take this like blocks away, would it still work? And is that even needed? Like maybe this is just grounding into the environment.
This is Joseph. This is me. Okay, I am this neon tube. I am not connected to Joseph. It's touching a piece. It's glass touching glass. But this is it. Joseph's scooter, Cameron's scooter. But from there, look, this seems like it's going even slower. So.
Wait a second, I just realized something.
Huh.
Cameron,
Yeah.
I have a question.
Yeah.
What's completing the circuit?
Tell me what's connected to what.
Well, I'm just looking at these wires
Okay.
and this coil. I don't know what's happening here. We know there's something happening. And maybe this is keeping the battery charged, right?
Could be. Well, when you read this, it's got amps and volts, right?
Okay, let me try turning this off because I have a feeling, because this actually, I think, is completing the circuit. The coil alone will complete the circuit. The question then becomes, are we able to help keep the battery charged with the interaction between the coil and this?
This is it. This is my suggestion for. We're not doing an experiment. We're not proving anything. But this is
We're doing an
Cameron's
experiment.
data.
No, we're doing an experiment, but we're not proving anything. We're
Cameron's
only, yeah, okay.
Cameron's data time. We take this motor out of. We can just connect these 2 leads to each other. We simply have a rechargeable battery attached to this coil. We measure this rechargeable battery and say this battery has such and such volts now. Then we leave it going through this coil and see if this battery has a higher charge the next time you come to it. An
I like
hour,
that.
2 hours,
I
5
like that.
hours?
Okay,
What do you say?
I like that, and I want to say something because you just reminded me of something I did the other day when I was experimenting with this. I wasn't making a video of it, but I thought we would do this as a test.
Yeah.
But we'll have more time hopefully next time.
Yeah.
Because today the main thing we did was we worked on the tire,
Yeah.
and we didn't stream that. I was thinking about streaming it, but I think we just got right into doing it.
Hey, we'll have the back one to do next time too. No, we'll have it down a little bit more, but it's still hard.
It's very hard. Yeah.
Yeah.
And so what I had done is, and I don't remember what I had connected, whether it was the coil or whether it was the, I don't remember what I had connected. Somehow I had the capacitor, this capacitor connected to the, to something out here, right? Something was connected, and it may have been this. I think it was this actually. And it did charge this capacitor. The voltage did increase a little bit. It did increase a couple volts.
Okay.
It did put some power. Now it's a big capacitor, I think it's 1 farad. I think is 1,000 watts. That's
Okay.
I read that.
Uh-huh.
I think Don Smith said that too. That
Okay.
a 1 farad capacitor is a 1,000 watt capacitor, if I recall correctly.
Does that mean a microfarad is a watt?
I don't know. I don't know. Well, I would have to look that up, like
Yeah. Yeah.
look up the translation. But so we do know that some energy is coming out of here,
Yeah.
and the question is. So then the question is, the way that we have this connected, right? Does it allow the battery to get some charge? And then is that
Yeah.
charge enough to keep this going, right?
I asked that question with an exclamation point on it.
It's a very good
Not just a
question.
question mark, exclamation point on that question. I think that's a good thing to know.
And let me just try turning this off and see if it slows down or speeds up. So it's not, so right now it's running off the battery because this coil is completing the circuit alone. But the question is having this on, are we putting charge back into the battery? That's right? That's our
Yeah.
question.
I mean, all we would have to do is just get the motor out of it, connect these two, and then you've just got battery and that coil and that Tesla coil running, and you can just look for a change in
Okay,
voltage.
let's try that.
So do you want to get a
Oh, wait a second.
first check the voltage of this guy
That's a good way to do it.
first? That's our first number with
Okay,
it not
we're
attached to
DC.
anything. It's not connected. As long
Oh,
as it's not
oh.
connected to anything.
By the way, when I was charging the capacitor with
Yeah.
this, I did have it going through the bridge rectifier.
Okay.
Right now, we're not using the bridge rectifier, but I still want to see what this does, right? We still want to look at this, right?
So now you're measuring the
What am I
voltage of
doing?
the battery.
Where does this go to?
But it also has the coil involved.
I would say I personally want to see what this is with no connection to the coil. You know, just to see percent
Oh, okay.
rise.
Okay.
Oh no, this isn't that. This
Yeah,
is
that's
that.
what I was
so,
doing.
So we're talking disconnect this. Yeah. What do we get coming off these two? This is
1.324.
1.324. Okay. That's the number. I'm going to type it into my notes. No one has to remember. 1.324 V. All right. I say leave this thing connected for an hour, and I say we speak in 1 hour.
So, how do I know which side to connect what? Just connect it and just connect. Just,
Wow, that's a good.
I mean, I'll have to see what the voltage is. Okay, so I'm gonna plug those in. Wait, where does this go to? Oh, that's not plugged in anything. So I'm gonna connect it, and then we'll just see if the voltage went up or down from where it was. Right? Let's try it that way. So let's go to volts AC and see if it's saying anything. Oh, it's AC. It's saying 2.7 AC. What's it saying DC? It's saying 1.287.
1.287 compared to 1.324.
Yeah.
And what is that? What's the 1.287 mean?
It's volts DC. Okay, hang on. Oh, that's when the coil's connected. Let me try connecting it the other way now. With the other polarity, if I say it that way. Right?
Yo-yo.
We're streaming.
Nothing exploded.
Close the door, please. Thanks. Okay, let me. I reverse the polarity. Let's see what the DC reads now. Oh, 1.31.
1.31.
That's higher.
It was at 1.324 before.
No. What's the last number I just gave you?
1.287.
Exactly.
So this is higher than that.
This is
So
higher
you're
than
saying
that.
it's connected,
This
right?
might be the right polarity, the right way to connect it.
So then we check and see if 1.324 is higher in an hour.
1.324. Yeah. Okay. Let's see
Yeah.
if it's going up or down. Is that what you're saying?
Yeah.
Okay.
But I should go. I'm gonna put my scooter in the car, get my burrito,
Okay.
half burrito, and get those. So yeah, I think if you can charge a battery from a Tesla coil, that's pretty cool.
So we need to just continue with like trying different things.
Yeah.
We have to just not give up ever. Never, 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 never give up. Never give up.
Too much fun happening so far.
Yeah. So
Family movies.
I'm gonna stop the stream, and then we'll continue.
Sounds good. And
When
you're
there's
gonna
time.
leave that running and see how.
Yeah, I'll leave it running. Yeah. I'll keep trying stuff. I'll keep trying things.
Awesome.
Okay, everyone. Thank you for watching the stream. Thank you for sharing your thoughts and videos and everything that you share. And we'll see you soon. Okay. Bye bye.